know that something is wrong because the function cannot come from negative infinity and negative infinity without having a maximum, right? So either this is wrong or this is wrong, or there is a max or a min. I mean, a max in here, a point of extrema. So something is wrong. So I know on that side I have to look again. From here, this is decreasing. So something is fishy. So I have to go back and look again. The limit from the left is negative infinity. That's correct. The limit to infinity is infinity. So these are okay. Now I'm checking back here. Negative 1. The top is negative. The denominator, negative 1. The top is always positive. So both are negative. Okay, let's see the first derivative. So 3x squared, x plus 1 squared minus x cubed times 2 times x plus 1 over this. That's correct. I factor out x squared, yes. I factor out x plus 1, yes. So this is out, 1 is out, 3 is correct. X squared is out, x plus 1 minus 2x. 3x minus, okay. So 3x plus 3 minus 2x. So I have x squared, that's why. Then I have x plus 3. Aha. It makes sense now. That's what it is. It's at negative 3, not at 3. So this is nice, but I don't need it. So f of negative 3 is what I need. And that's negative 27 over that. So that's positive. Yes. So this is approximately negative 1.7. Negative 27 over, no, negative, okay, don't rush. Negative 3 plus 1 is negative 2, so that's 4. So 27, positive 27 divided by 4. Negative 3, that's negative 27. Negative 3 plus 1 is negative 2. Negative 2 squared is 4. So this is negative 27 over 4. Approximately 27 divided by 4, what is that? 6.75. Yes, that makes sense. And this is, of course, negative 6.75, and this is the negative 3 that we just discovered. It made no sense. You understand why, right? A function cannot go from negative infinity to positive infinity to negative infinity and back to negative infinity without having a max. It's not possible. So this is negative 3. I'll let it dry for a second. Okay, let's see the rest. So, yes, it makes sense. From negative infinity to negative 6.73, it's increasing. But then the 0 is here, okay, and not on the other side. And now I have to study the sign again. So, with a plus, of course. Good. So this is positive. To the left with negative 10 is positive. That's correct. To the right, so this is negative 3. So with negative 2, positive over negative. So this is negative, which it has to be. Otherwise, it will not have a maximum. So that's negative. Then at negative 0.5, positive and positive. Good. With 10 is positive. Good. Okay, so then one more time. From negative infinity to negative 6.7, yes, and then it decreases. It makes sense. From negative infinity to 0, yes, that's correct. From 0 to 1.7, absolutely, but I don't need it. I'm going to erase it to infinity because I don't need this value. Good. So everything is done. Now I have to differentiate this and see what happens. One more time, from negative infinity to the maximum. This is a local max. So this is 0 here, and this is positive. So this is local max. Comes to negative infinity. From negative infinity, increasing, crossing the x-axis, always increasing to positive infinity. Yes, that makes sense because of the slant asymptote. Here, yes, it makes sense because it's a slant asymptote and it has a maximum. Good. So I expect on this side, because it has a maximum, I expect the second derivative to be negative. And on this side, also negative. Well, we'll see. I have to show that and justify it with calculations. Okay. So I know what to expect now. It's much better. Good. So where is it? Right here. I'm going to rewrite the function, the first derivative, like this to make it so much easier. X cubed plus 3x squared over x plus 1 cubed. Okay, I'm going to differentiate that. Although, at this point, I know what to expect. I know that this has to be this, and this has to be this as well. Why? Because it's coming from negative infinity going to positive infinity. There is no other way. But we'll see in a moment. The denominator is x plus 1 to the 6th power. The numerator, 3x squared plus 6x times x plus 1 to the 3rd minus x cubed plus 3x squared times 3 x plus 1 squared and times 1. Okay. Do not multiply. So x plus 1 squared. So here I have a 3x squared plus 6x and times an x plus 1 and minus. I could have factored the 3 as well. Too late. So minus 3x cubed minus 9x squared over x plus 1 to the 6th. Good. So what do I have here? 3x to the 3rd plus 6x squared plus 3x squared plus 6x minus 3x cubed minus 9x squared over x plus 1 to the 4th. These two go away. This is minus 3x. No. Very nice. So I only have left a 6x over x plus 1 to the 4th. It cleans up very nicely. It's done with computer algebra. I'm pretty sure that that's how they come up with those functions. Okay. So
can you go back to this page? How did the 3x squared cancel out?
3x squared plus 6x squared is 9x squared with minus 9x squared.
Okay.
No, I make mistakes too. As you saw, I copied a negative instead of a positive, so I'll rather go back. Do you see anything else? I'll rather go back and check.
No, I think I will.
No, let me check. So just to make sure. So 3x cubed plus 6x squared plus 3x squared and plus 6x minus 3x cubed and minus 9x squared. So 6 plus 3 is 9, minus 9 is 0. These two are gone, and then 6x. Okay, so apparently it has an inflection point. I did not expect that, but that's fine. So x equals 0. Perfect. No problem. So at 0 is here. And the sign is only given by this piece. Everything else doesn't matter. To the left of 0 is negative. It has an inflection point, fine. And to the right is positive. I wasn't expecting that, but that's okay. Good. Very nice and easy, actually. So inflection point. Done. It's not symmetric. Actually, it is symmetric. Okay, so f of negative x is negative f of x. Because this doesn't No, it's not. It's not. This one changes into negative x plus 1. It's very unlikely that a function with a slant asymptote will be, but not unlikely, but it's, you know, possible, but not very seldom. Okay, so now we have to find the slant asymptote. X squared times what is x cubed? X. Go back. Negative x cubed, negative 2x squared, and minus x. Negative 2x squared minus x, and this is negative 2. Negative 2x squared, positive 2x squared. Negative 4x, positive 4x. Negative 2, positive 2. So this is 3x plus 2. So our function that's my page 6, our function will look like this. Quotient x minus 2 plus remainder over the divisor. This is the slant asymptote. Good, that's all we need. Done. I will start by graphing the asymptotes. And the function has x equals negative 1 and x minus 2 as asymptotes. Y equals x minus 2. So here it is. X equals negative 1. Remember how to determine 2 points here when x is 0, y is negative 2. So 0, negative 2. When y is 0, x is 2. So I have to extend, just make sure. Maybe I don't need it, but I think I do. So y equals x minus 2. So I'm going to write it lower. Okay, so I plot my points next after I graph the asymptotes. I plot the points. And which points do I have? I have negative 3, negative 7 roughly. So 1, 2, 3, 2, 3, 4, 5, 6, 7. So somewhere here. That's my 1 point. And the origin. Nice. Okay. So from negative infinity to the maximum, to the local maximum, back to negative infinity, opening down. Piece of cake, right? We knew that. Okay. Then from negative infinity to the origin, and at the origin, it changes concavity and approaches asymptotically. So this way. And changes concavity to approach asymptotically. And this is the function. Very interesting, very nice function, really. They came up with a very interesting situation. So now you see how valuable this is. Very easy to catch your mistakes. There is no way the function can go from negative infinity to negative infinity without coming through a maximum. There's no way. When I realized that and I saw my sign, I said, uh-oh. And then I found my mistake. Here I was expecting it to do this, but that's fine. So it goes to an inflection point and then goes asymptotically approaching the asymptote. Y equals. Of course, you can always go back and check with the graphing calculator. Let me show you again. As we discussed last time, you have to punch in the asymptote as well. So that is x minus 2. Okay. And the function, make sure that you put parentheses. The top, because it's one term, it's okay. It works without parentheses, but be careful about the denominator, that was x plus 1 squared. And then I know I will, of course, the standard viewing window works because we graph the function. So as you see, the function it opens down till the origin and then changes concavity and opens up, approaching the slant asymptote. And here that was the indication that it had to have a maximum. It can come from negative infinity and go to negative infinity. Very good. Next question. Any questions?
Can we do number 42 from the same section?
Yes. 42. Where is 42? What are we asked in 42? Okay, the same thing, everything? Good, so this is our review. That's perfect, really. We don't have to do this when we review for the test, because we had plenty, I think, I hope. 42. So y equals 1 minus x, e to the x. Great job. Good, so I get my table started with f prime, the function, and the second derivative. So, can anyone give us a domain of this function? Are there any situations here? Anything to worry about?
The domain is from negative infinity to positive infinity. Isn't
Absolutely, yes. Absolutely, yes. And it's 0 at 1. So at 0 is e to 0, which is 1. At 1, I already see that when I set this equal to 0, the only option is 1. And now I have to determine the limits, and it's done. There is nothing else I have to determine here for the function. So the limit as x approaches negative infinity from 1 minus x e to x. So let's discuss this. Where is this going as x approaches negative infinity? Anyone?
1 plus 0.
Excellent, very good. So it's e to negative infinity, which is 1 over e to infinity, which is 1 over a big number, which is 0. Awesome. What about this? Where is this going?
Positive infinity.
Yes, it is. So what is the situation we are encountering here? It's 0 times infinity, which is an indeterminate case. So we have to determine this. Good. So let's see how we get that. Remember what we said about a product? Normally, a simple algebraic change of the function will do the trick. Okay. So if we have limit here as x approaches negative infinity, one option would be for this situation to write this, right? So 1 over, so this will be e to negative x. So I'm changing e to x into 1 over e to negative x. They are the same. 1 over e to negative x is e to the x. And now what I'm looking at is infinity over infinity. The top goes to infinity, positive or negative is not important, and e to negative infinity, e to negative x when x approaches negative infinity is e to infinity, which is infinity. So I will continue with L'Hopital's rule. The top prime is negative 1, and the denominator is e to negative x times negative 1. So this is the limit as x approaches negative infinity. These two go away. 1 over e to negative x or e to the x power. Same thing. So negative x, when x approaches negative infinity, this is infinity. And 1 over infinity is 0. Or e to negative infinity, as you gave it to me here, same thing, is 0. So if this is 0, I will make myself a note that y equals 0 is a horizontal asymptote at negative infinity. Y equals 0 horizontal asymptote. At negative infinity, I did not check infinity yet. So now I'm looking at the other side. As x approaches infinity, 1 minus x e to x. Where does this go?
0.
Careful. I'm on the other side with infinity, right? So this one is infinity, yes. Okay, what about here?
Would be infinity.
Yes, sign is not important. No, sign is important. So because I have x approaches infinity, so this is negative infinity. And now I have to multiply negative infinity by infinity and get the answer.
In negative infinity.
That's it. Awesome. So this is it. I don't need anything else. I cannot determine anything else. There is nothing else. Now the first and the second. F prime. Let me write the function right here. So it's 1 minus x e to the x, or negative x minus 1 e to the x. One or the other. I prefer this. Negative outside, the first function prime is 1 e to the x plus x minus 1 e to the x. Factor e to the x, and I have 1 plus x minus 1. Really? Very nice. So negative x e to the x. And this is 0 only when x is 0. Study the sign. This is always positive. I don't even need to look at it. To the left of 0, this is positive. And to the right is negative. Now the moment of truth. That's when I catch my mistakes. Hopefully I don't have any, but we'll see. So this is definitely a local max. From 0 to 1, yes, that's okay. From 1 to 0, yes. From 0 to negative infinity, yes. Second derivative. This is the first. Very nice. So negative 1 e to the x plus x e to the x, and this is negative e to the x and x plus 1. And this is 0 only when x is negative 1. Well, at least they didn't crowd my, thank you very much. They didn't crowd my table. Okay, so this is always positive, but to the left of negative 1, this is positive, and plug in numbers. So positive and negative. So to the left of negative 1, if I plug in negative 10, this is negative, but there is a negative in front. If I plug in 10, 10 plus 1 with negative in front, it will be negative. That's it. Quite a quick function. That was nice. No asymptotes, no problems. Okay, I plot the points first. I need a number here. So this is 2 over e to the x. So f of negative 1 is 2 over e. I need to approximate that. So how much is 2 divided by e? 2 divided by e. 0.7. Without this number, I cannot plot. Okay. So asymptote is right here. I don't need to. This is an overkill because the horizontal asymptote is the x-axis. Then at negative 1, I have 0.7. At 0, I have 1. At 1, I have 0. Good. So the function starts at the asymptote, increasing to this point, which is the inflection point, changes concavity, opening down. So it opens up, coming from the horizontal asymptote to the point of inflection. Okay, let me choose a different color here. Opening up from 0 to 0.7. Changes concavity, gets to a local max, crosses the x-axis, going to negative infinity. And that's it. And the function that we graphed, we always have to write 1 minus x e to the x. Always write next to the graph on paper what you graph.